Hello, CheersKevin here, and today we're going to learn how to write kOS code. We got KSP, CCAN, kOS, and Visual Studio Code set up in the last video. Actually, funny story. So, right after this series launched, there was a new version of Kerbal Space Program that dropped. But we can go back and revert things back down, because unfortunately it means that the mods aren't compatible until all of the mod authors go through and update things. We can go over into this beta tab via Steam and say, hey, I would like to be on 1.4.1, please. And now we're ready to learn to program. In the next, 20 minutes, we'll go over the syntax and semantics of KerboScript, how every program is made up from a series of instructions. Each instruction can be one of many different types of statements. Each of those statements must end with the period character, with the sole exception of the instruction block, which is itself made up of a series of instructions surrounded by left and right curly braces. From there, we could make an orderly exploration of each different type of statement. The empty statement, the set statement, the if statement, and so on and so forth. There's just one problem. This is a terrible way to learn to code. This series is designed specifically with newbies in mind, and that means that some of you have never written a line of code before. That can be intimidating because you're still learning things that those with more experience may take for granted. And in any tutorial, well-meaning programmers may forget to cover the basics. A string is a series of characters usually surrounded by quotes. Curly braces are shift modifier keys on the right side of your keyboard above the return or enter key. But I want to caution you against trying to learn all this theory from the ground up. It's way too easy to burn out, treating programming as a theoretical discipline. If you wait until you understand it all, you won't ever make anything cool. Instead, we're going to take the same approach to coding as most of us did when we first started playing with Kerbal Space Program. We'll put something together, throw it out on the launchpad, and watch it crash. The goal in this video is to do three things. We'll set you up with boot files so you can write code that fails fast. Then we'll learn the fastest way to code: plagiarism. Finally, we'll learn how to debug code fast, and maybe also get a rocket into space. In a prior video, we set up Visual Studio Code as the editor that we are going to work in. We created a workspace folder, and I didn't really understand how that worked, but we're going to go ahead and open it again. I'm going to go into the Kerbal Space Program directory and select ships and script. And inside here, there may or may not be a folder called boot. We'll get to that in just a moment, but we'll go ahead and click add. And we have our hello.ks file that we created in the first video. We don't need to understand what any of this does. We wrote it last time and it worked well enough. So I want to create a new file, but first I want to save this workspace because this will be nice to kind of stick around. We'll go ahead and file, save workspace as. And we'll save it in here. I'll just say K for N. kOS for noobs, save, done. And now we have this lovely little workspace. We can close it and open it, and it'll persist some of our settings, which will be nice. Okay, I want to create a new file, and what we're going to do in this, the rest of this video, is walk through a bit of code that we didn't have to write, and I want to teach you how to debug it, how to figure out what the heck is wrong, why stuff isn't working, because you're going to need to do a bunch of exploring on your own whenever you're writing your own stuff, and one of the most challenging things is figuring out what's actually wrong. So we're going to create a new file. We're going to call it debug.ks. And at this point, I'm going to copy and paste some code, and you can go ahead and do the same thing. You can play along at home, copy and paste the code from the description of this video. It'll be right down there. Go ahead and expand it. Don't forget to click Patreon while you're there. Go ahead, So we've got our editor. It's all great and wonderful. I'm going to close hello.ks. I'm going to close this Explorer drawer as well. I'm going to hit F11 and full screen this baby. And we've got a broken launch script. And right now, I'm assuming that we have no idea how KerboScript works and what any of this code means. That's fine. We're not trying to figure out what it means. We're just plagiarizing. So here we are with our craft. We're going to go into kOS. We're going to pop this terminal open. And one other thing that you can do, discover this, you can update the default font size. If you change this number, then after you refresh, well, then you pop this open and it's going to be a little larger, a little bit easier to read, which is nice and convenient. So what are we going to do? We're going to type run path and then open paren and quote and 0:/ because it's on the 0 drive. This is the file that we just wrote, debug.ks, and that's in our ships script folder. I'm going to type debug.ks and close this all up, and then we're going to put a period at the very end and say, all right, let's go ahead and run this. All right, so here we go. Now we have some broken code. This is something that you're going to encounter whether you're plagiarizing other people's code that may be old, whether you're writing your own code. You're going to find these sorts of errors, and it's important that we figure out how to deal with this nonsense. Right here, we're getting this verbose description. Well, let's look at all this. First, it says unexpected token closing curly brace found. Expected EOI at line 5. Okay, well, at least it gives us a line. Until ship max thrust is greater than 0 stage. We get this verbose description that says the parser used by kOS is complaining about a part of the blah, 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 blah. Okay, this isn't helpful. This it's not giving us a ton of information. Here's something that is helpful to know when you're looking at these debug statements. A lot of times, when there is an error with a particular piece of code, the problem is just before it. It may be at the end of the line before it, or in this case, it may be a couple characters before, because it's not really saying, hey, there's something wrong with this curly brace. It's saying, hey, I wasn't done doing stuff. Why are you giving me new information? And EOI, and this is just specific to KerboScript, EOI is a symbol called for end of instruction. In this case, EOI actually means the period character. Well, in all cases, it means the period character. It's saying, hey, I was expecting a period character, and instead I see this. Well, why would it have been expecting a period character? Well, if we look back at the line here, this stage command, even though it's in these curly braces, doesn't have a period after it, and every time that we give an instruction to kOS, it needs to have a period after it. So all we have to do, we have to look for line 5. Thankfully, we have these line numbers here inside our editor, which is great. We'll go to this stage command, we'll put a period there, and we'll hit save. You see it has this little thing there saying that it's unsaved, and yeah, there we go. That's all that has to happen. These curly braces, by the way, and this is true of many languages, they are a way of grouping a bunch of code. So we have until ship max thrust is greater than 0, we can say, hey, until that thing is true, stage and also print whatever. Or these basically the stuff that's inside the curly braces can be treated as a group of instructions. That's why these curly braces exist for the most part. And thankfully, I can just hit the up key, and we'll do that. Now we get another error, and this one is hard to figure out. Unexpected token A found. Expected EOI at line 12. All right, unless apoapsis is greater than 100. All right, that's the line. Let's go back and look at our code again. Unless apoapsis is greater than 100. By the way, you can also twirl these down, which is kind of convenient and fancy. It's just a quirk of the editor. Unless, and it says, hey, at this A character, I was expecting an end of instructions. Okay, let's appease it. Except that doesn't really seem to make any sense, right? Because we're saying, hey, unless the apoapsis is greater than 100, go ahead and do all of this stuff, right? So really putting a period there isn't going to solve the problem. Something is wrong with this instruction, and we don't really know why. So we're going to try a different, we're going to take a different tack for debugging this. We're going to type 2 slashes, and that's going to comment out this line. What that says is, hey, kOS, if you see this whole line, just ignore it. And we'll type our own little command. We'll say, unless true. We're just going to try and simplify it. And of course, it's going to type in the closing curly brace for us. We're just going to try and simplify this command because maybe there's something up with apoapsis that's causing a problem. We'll say, unless true, open the curly brace, then do all this stuff. Up arrow once more and enter. And no, now it says unexpected token T found. So it's not the apoapsis that's part of the problem. This whole line, it's saying, hey, I expected that end of instruction. So something is wrong with the instruction, and either it's both this and this, that even our simpler version of things also broke for the same reason, or it's something to do with this unless. And if we put a period there, that seems to break up our instruction. We know intuitively that that doesn't make sense because this is atomically what we are trying to say, that, hey, this is a grouped statement, unless blah, that's our instruction. So what could be wrong? If we look through the rest of the code, this is a case where actually syntax highlighting helps us out. Syntax highlighting isn't perfect, but we see up here they're saying until ship max thrust is greater than 0 stage. Until is probably what was meant here. It turns out that unless isn't a keyword at all. In fact, if we go over to the kOS docs, we can double check that. In the kOS docs, I'm just going to type unless. And you see, okay, we've got these things, but it's not actually giving us much information. There aren't any keywords that are jumping out. If we type in until, we're probably going to get more, flow control. And now we've got some code examples saying, hey, until 0, blah, 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 all these things. So unless isn't the right keyword. If we jump back over to our code, we can maybe change it to something more appropriate. So we'll uncomment this and we'll delete this line. And instead, we'll just say until. Until apoapsis is greater than 100. And that actually kind of makes sense. If we look at the ship available thrust is less than available, blah, 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 something to do with staging. Something to do with staging up until our apoapsis is over 100, right? So until seems to make sense here, and not just an unless, because unless implies you'd only do it one time, but until means you do it multiple times. So in this case, we're looking at the rest of the code to give us some hints as to, hey, maybe this is a better approach here. Let's jump back over to the launchpad to see if it works. And finally, we seem to be working. All right. We are burning fuel. Now we have no fuel. So it's not really gonna matter if we fix any sort of bug, we're gonna have to revert, right? Now, when we're creating crafts, we can revert to launch, we can revert to the vehicle assembly building, and we ideally wanna have the same sort of workflow for working on our scripts. When it's just an issue of syntax errors, then we can just try and run it a couple of times until it actually runs. But in cases where it actually does a thing and we need to reset the craft, well, then we're going to need to revert to launch as well. But I'm actually going to revert to the vehicle assembly building first because I want to talk to you about boot files. So here in the VAB, we've got our kOS part, and you're going to see, hey, we can configure our disk space, but there's nothing to do with this boot file that I've just mentioned, and that's because we actually haven't created any boot files yet. So we're going to jump back over to our editor and fix that. So let's open our project drawer real quick, and I'm gonna go ahead and just create a new file inside boot, and I'm gonna call it firstboot.ks, dosboot.ks. All right, anyway, we'll say print hello as just a basic test of our boot file. We'll go ahead and save that. Unfortunately, if we click here, there's still no boot file. In fact, you have to reload in order to get the boot files to show up. It's a little unfortunate, but that's okay. We can just go ahead and open up Kerbal X++, again, load it. Now there's this dropdown for boot, this select for boot files, and we can go back and forth between, hey, none or this particular file. It finds that, it says firstboot.ks. So that's wonderful. Let's go ahead and right click. We'll leave that boot file selected, and we'll jump out onto the launchpad and see this in action. Now we're out here and we don't actually see anything because we have to open the terminal, but it now says hello. So this happened immediately once the operating system came online. So that's fantastic. Let's go ahead and modify our code to, I don't know, maybe stage the craft. So I'm gonna go ahead and say, let's go to space, and then I'll say stage and stage and stage. Now ideally what I'd like to do is just hit escape and revert to launch, right? We'll go ahead and revert flight. We'll revert to launch, and then it'll pick up the boot file and go ahead and run it, right? Huh. Well, it's not doing its staging. If we open this up, we're actually running on an older version of the boot file. Now, this happens when you revert to launch with the boot file because it's attached to the actual craft. If we reverted to the vehicle assembly building and then came back out of the launchpad, it would update the boot file. So what we're gonna do is use a two-file strategy. We're gonna have a boot file that we don't change. All it does is run our other file, because then it'll go ahead and pick up those changes, because the boot file can stay the same from launch to launch, and then we can revert to launch over and over and over again until we get our script just right. In here, I'm gonna create a new file under boot, and we're just gonna call this let's call this boot.ks. And this is gonna be our basic boot file. And we're gonna go ahead and say run path, 0:/, and we'll say debug.ks. So debug.ks is where we're actually going to be revising our program and going through and debugging it, but we don't need to change this boot file every single time. If it stays the same, that's perfectly fine. One other thing that I'm going to add at the very top here I'm going to copy and paste this in. Core part get module kOS processor do event open terminal. This is just going to pop open the terminal right away as soon as the thing launches, so that we don't have to worry about going and clicking that thing open every time. This means we revert to launch, it pops open the terminal and then runs that file. That's all that we want our boot file to do. We want our boot file to be very, very small and do the heavy lifting in the actual code itself. Back in the VAB, I'm just going to swap over our boot file to boot.ks, and immediately we're back to where we were before. But this time, we don't have to do any typing to get the thing to start. We'll go ahead and revert to launch real quick just to make sure it's not a fluke. This thing pops open, runs the program, and now we can just work on fixing it. Revert to launch, quickly, iteratively try to fix the problem, come back, try to fix the problem, come back. We're not gonna have to spend a whole bunch of time clicking things open, running particular files, and all of that nonsense. This is the more difficult part of our debugging process because the code isn't broken. It's not causing errors. It's doing what it thinks it's supposed to do. It's just not doing what we want it to do. So let's look through this code and try and see if we can figure out what is going on. So we're locking the throttle to 1. Let's assume that's fine. Stage, okay, that's pretty self-explanatory. Until ship max thrust is greater than 0 stage. Okay, so it should stage until it has some available thrust, but it has that on the first stage, right? But it's in the launch clamp, so maybe this never fires. Lock target pitch, no idea what that does. Set target, no idea. Of course, I wrote this. I'm pretending to have no idea, but let's say I have no idea. Let's try just giving it a shot. Let's put some extra stages in here. We just 2, right? Because first we fire off the first rockets, and then we detach ourselves from the launch clamps. Let's go ahead and save that. Nope, same problem. This is actually one of those cases where this is a quirk of kOS and not something that's really our fault. The problem actually lies with the fact that if you stage, it can take a second for it to realize that it is staged. If you have 2 stage commands right after one another, it's not always going to take them both. So we're going to put in a wait command, 0.1. We'll say wait for 0.1 seconds, and this is just something you're going to have to learn as a quirk of kOS. Now, of course, since we're doing this initial staging, this whole wait until we've got enough thrust thing doesn't seem to make much sense. So I'm just going to go ahead and, well, I could delete it, but instead I'm going to comment it out so we can use that code for reference later if we find it useful for some strange reason. Now, it still doesn't seem to be working, and I think this may be just because it fires up before the ship is fully loaded or some strange thing. Let's try just increasing that wait time. All right, I changed it to let it wait a full second this time, and it looks like that seemed to work. A little bit. All right, well, so we've got some explodes. Okay, well, for some definitions of working. If you watched the last video, you may think that the solution is obvious, that we need to add wait until false. And I would applaud you for that, because so often the issue with the program is that, hey, the program did everything it was supposed to do, now it's done, and so everything shuts off, and then everything crashes. But in this case, if we look at the lines immediately above, we're locking the throttle to 0, and we're locking the steering to prograde. If we lock the throttle to 0, well, that's also going to make us crash, right? So what is this supposed to actually do? It says, okay, until the apoapsis is greater than 100, and that means it should continue to stay up here until our apoapsis is over 100. So that's very strange. Why is it that it's somehow getting out of here? And this is what it's supposed to do. Inside these braces, it's supposed to run this code over and over until our apoapsis is greater than 100. Well, we're going to apply yet another debugging technique. We can go ahead and keep this wait until false in here. That's perfectly fine. What I want to do, let's see, we're going to ignore this available thrust. We don't even really care what's happening in here. What we care about is, hey, how are we getting to either the end of the file or even this lock throttle to 0? We don't want to be here yet. Let's go ahead and add a line inside here. And unfortunately, this thing is set for 4 spaces, and I don't like 4 spaces. I want to use, indent using spaces. I want to use 2 spaces. Thank you for my indentation. Wonderful. We're going to type print apoapsis. So we don't care why it's leaving here, but we want to see, hey, what is this value? This is what we're trying to test, right? What it's testing. It's saying, hey, until this thing is greater than 100, it should be in here. So let's print out what the values are, and we can see, hey, when does this reach 100? So immediately, oh, there we go. Okay, so this is sort of, now we can sort of see what might be going on. In fact, it's using meters and not kilometers. So waiting until our apoapsis is 100, well, it did just that. In fact, this is the problem, is that whenever we're dealing with numbers in kOS, we're generally referring to meters, not kilometers. So saying, hey, let's do some stuff until we get to 100 kilometers up, which is a normal, rational thing to do when you're flying manually. We need to say 100,000 meters up. So fair enough. Let's go ahead and just add 3 zeros to the end of here. Well, we don't need the period actually there. And we can leave this line in, but I'm going to go ahead and comment it out. And let's jump back over and see where we're at. All right, here we are, the moment of truth. Let's see what's actually going on. It does seem to be tilting over. It seems to be running. And now here's a question. Is it actually going to do what it's supposed to do? Well, it hasn't staged, so that's unfortunate. Wonder why that might be. We're carrying along this payload, but we're at least getting our way sort of to space. Not, as efficiently as we might have hoped, but it is something. Here we're going to look at the body of this until apoapsis is greater than 1,000 thing. If ship available thrust is less than avail thrust minus 10, Okay. If available thrust, if the thrust that we have is less than some random thing that we don't entirely understand yet, then we're going to stage and wait a second, and then we're going to set avail thrust. Okay, so that's that same keyword there. In fact, if we double click this, we can see where it's used in all these these three places. Set avail thrust to ship available thrust. Now here, this is another, I've kind of added in this bug to illustrate something that is liable to crop up from time to time. Avail thrust is set up here. We're saying lock avail thrust to ship available thrust. So that's fine. That is whatever the available thrust. What we're trying to do is we're trying to say, hey, what is the available thrust right now? And then we're going to track changes in the available thrust so that we can say, hey, if the available thrust suddenly drops from what it used to be, well, that means we must have flamed out. We must have a stage that needs to be discarded, so we'll go ahead and stage, and then we'll say, this is the new available thrust that we have. So, and that seems fine. There's one keyword here that is wrong, and I'm going to see if we can try and figure out what that is. To do that, I'm going to use that same printing out strategy. I want to print out in here two things. Ship available thrust. There we go. We can autocomplete. That's lovely. Just by hitting tab. And I'm going to print, and actually I'm going to go ahead and print in quotes available and plus that. And I'm going to say print, I guess, old. Because we really could call this like old thrust, right? In fact, let's do that. Let's call that old thrust. And I'm sure there's probably some keyword by which I could replace all the instances of this, but I'll just go ahead and do that manually. So we'll rename that just to make it a little clearer, and then we'll say plus old thrust. And so we'll print that out and just see what sort of information it can tell us. And now this is a little bit hard to see because it's scrolling so quickly. We're going to go ahead and if I just hit escape here, we can pause this, and you'll notice something. I could have used the characters that would make this line up. These values are identical. And not only that, they're identical and they're changing. They're changing equally. But that's weird because our old thrust shouldn't be continuing to update. So there are actually two keywords that we're using. One is set. Here inside here, after we've staged once, we'll set the old thrust to whatever the available thrust is. But up here, we're using the keyword lock. And lock is a fancy keyword. In programming, you have this concept of variables. I may say set x to 5. And then whenever I want to say I want to print x, and it should say, hey, 5. Or I want to say print, x plus 2, it should say, hey, 7. Because we've assigned this x term to mean that thing. The keyword lock, if I were to say lock x to something, the way that kOS interprets this is that it says whenever anybody asks me about x, I'm going to calculate x anew from whatever the right-hand side of this expression is. So when we say lock old thrust to ship available thrust, it's not the fact that these we're using capitals or underscores, because kOS doesn't care about that. That's in there to kind of throw you off. We're locking this, and it means that every single time we say, hey, what is old thrust? Well, it's going to say, hey, cool, let me look that up for you. And I'll go ahead and figure out what the available thrust is. And I'll say, hey, you wanted the old thrust? It happens to be exactly this number. So we're not actually freezing the value. We're saying, hey, make sure that old thrust always updates to be the latest and greatest version of whatever this right-hand side of the expression is. This is very helpful up above here when we're saying, hey, we're locking a target pitch, we're locking our steering, because we want the steering to say, hey, I always want to be pointed in such and such a direction, and I'm not setting it, I'm locking it. You also lock the throttle. I don't want to say, hey, set the throttle to one thing at one point. I want to lock it to a particular value, or I may lock it to an expression. In fact, in this case, the target pitch is something that's going to vary with the radar. We're not really going to get into that. We'll leave that alone for now. But that's the difference between set and lock. Set says, hey, look at this value at one moment in time. Take a snapshot of it and set it to that keyword. Lock is going to say, hey, anytime anybody asks you about this, this is what you should tell them. And kOS is going to remember that. So we'll change this to set old thrust to ship available thrust and hop back over into our game once more. And now at this point, if we pause, we can see that, hey, the old value is not updating. It is remaining constant because, hey, it figured out what the old value was at the time that it was called. We're only going to update that value after we've staged. We'll go ahead and just let this thing move forward a little bit. Actually, I can go ahead and physics warp. And there we go. We're staging just fine because it detected that, hey, there was a drop in our available thrust. It went downward. And yeah, we're not thrilled about that. And of course, now we're staging. We're getting our way up to space. We're dealing with this curvature, which I think we'll probably talk a little bit in the next episode, trying to deal with our gravity turn. But now we have a very efficient way to get to space. And we did it all through stealing code that we didn't have to write. What we did learn is how to debug these problems, figuring out, hey, when there are issues with these graphs, how do we go about fixing them? What are some of the common errors that we're going to encounter with kOS? So I'd encourage you to go back and look at that script. Try commenting out lines that don't make sense to you and see what the heck happens. Or try adding new things of your own and seeing, hey, can you make things crash? And if they do crash, can you figure out what the error messages mean? If they don't crash, then it's probably the case that your kOS interpreter is doing exactly what the code tells it to do. You just may not have expressed exactly what you wanted to have happen. Now, going forward, I'm not going to spend as much time kind of going back and forth trying to debug these little issues. I wanted to take the time here to really walk you through what that process looks like so that when you encounter the inevitable thousands of errors that you're going to find, you know what to do. Having the boot scripts there, popping open the terminal automatically, it's very, very helpful. Being able to revert to launch the same way that we do when we try to manually pilot things is incredibly helpful. So I hope that this has been helpful, and I'll see you next time.